Hey guys, today we're going to be looking at another dynamics question where there is a pulley system with two masses hanging on it, and the question is going to be asking us what's the acceleration of one of the masses. And with these pulley system questions, it's important to note that there is no friction between the pulley and the string. Okay, so you can try to pause the video and solve it for yourself, and then come back when you've finished. Alright. So, with all of these dynamics questions, it's really useful to draw free body diagrams of the forces that are acting on each of the objects. So let's start by looking at M1, or the 15 kilogram mass. So here we have M1, and on it there's going to be the tension force upwards, and there's going to be the force of gravity, which I call M1G, downwards. And this tension force is just the force that the spring pulls on it. And you might notice that I drew the arrow for the tension force bigger than what I drew the arrow for the force of gravity. And that's because I know that the tension force is going to be larger than the force of gravity on M1. And the reason why the upwards tension force is going to be larger than the downwards gravity force is because this 15 kilogram mass, which is lighter than the 25 kilogram mass, is going to move upwards. Okay, now let's look at the forces on M2. There's still the tension force pulling it upwards. And notice that I drew the tension force on M2 the same size as the tension force on M1. And that's because a string pulls with the same force on both ends of it, no matter what. And I'm also going to draw the force of gravity on M2. M2G. And if you can see here, the force of gravity on M2 is greater than the tension force. And the reason why it's greater than the tension force is because this larger mass is going to go downwards. So the downwards force must be greater than the upwards force. And it also makes sense that this M2G is greater than M1G because obviously the force of gravity on a 25 kilogram mass is going to be bigger than the force of gravity on a 15 kilogram mass. Okay, and we can use these two free body diagrams to make a system of equations using F net equals ma, or Newton's second law. So F net, which is the sum of all forces, so on M1 it's going to be tension minus M1G equals ma and M1a, and for M2 it's going to be M2G minus tension equals M2a. So there's a couple things I did here which I should explain. So first of all, these two A's, I didn't write A1 and A2, I just wrote A. And the reason why I used the same variable for both of them is because these two masses, which are connected by a string, are going to accelerate with the exact same magnitude. Right? This mass is not going to suddenly shoot down while this mass goes up slowly, because they're connected by a string and this string doesn't stretch or anything. And so that's one thing. And another thing is that for the smaller mass I did tension minus the force of gravity, and for the larger mass I did the force of gravity minus tension. And the reason why I do this is because what I should be doing is just adding the two forces up. And this acceleration for M1 should be upwards, and this acceleration for M2 should be downwards. So, if I took into account direction, what would happen is I would have the tension force upwards, plus the force of gravity, which is downwards, so it's going to become minus. And because it's a bigger force minus a smaller force, this M1a, this acceleration, is going to be upwards. So if I take into account direction, I get this equation. And you can do the same thing for this equation by flipping the direction and making downwards positive and upwards negative. Okay, so now that we have the system of two equations, let's plug numbers in. So this tension remains a variable, so tension minus M1 is 15 and G is is 9.8 equals 15a. And here m2g, which is 25 times 9.8 minus tension equals 25a. And if the tension minus m1g and the m2g minus tension is still confusing you, it's always useful to remember that if you want your acceleration to be positive, you always do the bigger force minus the smaller force. So as you can see here, this bigger force of tension minus the smaller force of m1g, and as you can see here, the bigger force of m2g minus the smaller force of tension. And these accelerations, I made them both positive so that they would be the same variable. But in general, you should always do bigger force minus smaller force. And that's what I did here. Okay, so I have a system of equations with two variables, and I want to find what's the acceleration of the 15 kilogram mass. So let's isolate for tension in this second equation. So 25 times 9.8 minus 25a equals tension. And then let's plug this T, tension, into this equation. And remember, because it's a string, the tension force is going to be the same. So I can safely plug it in. I can get 25 times 9.8 minus 25a minus 15 times 9.8 equals 15a. Okay, so I have one variable, and when you solve for a, you get 2.45. But, as we all know, acceleration is in meters per second squared, and it has a direction. And if we want to see which direction this 15 kilogram mass accelerates, well, the first thing we can do is we can look at our free body diagram, and we can see that this tension force is greater than this m1g force. So, it's going to go upwards. And we can also think about it logically that the 25 kilogram mass is going to fall downwards, and the lighter 15 kilogram mass is going to go upwards. So, the answer is 2.45 meters divided by second squared upwards. Okay, well, I hope that made sense and you understood the explanation, and thank you for watching the video.